Thank you so much. Thank you so much for joining us today. It's truly an honor to speak with you and to share your remarkable insight and experiences with our AstroTeach audience. We've been really excited about this conversation. Your work on gamma ray bursts and the large scale structure of the universe has inspired many learners around the world.
My name is István Horváth. I'm a physicist and an astronomer. I was born and raised in Debrecen, the second largest city in Hungary. As a child, I was fascinated by the night sky. I was 6 years old when the moon landing happened. Many times in the playground, we imagined there is a spaceship there and played that we are astronauts. Behind the Iron Curtain, we didn't know Star Trek, but we had a German series, Spaceship Orion, so I dreamed of being an astronaut. But I thought, let's be an astronomer first, or just an amateur astronomer. As I said, I was fascinated by the night sky. I could only see the beautiful night sky just several times a year, because from a city of 200,000 people, only the brighter stars were visible. But luckily, my grandparents lived in a village, and in the 70s, the street lighting wasn't very bright. The back right away from the street was excellent for observation. Every September, there was an astronomy week in the city. I listened to the lectures, then later I went to the astronomy club every week. One could borrow binoculars and 6-centimeter telescope from the club. So I admired the Milky Way and watched the deep sky objects like globular clusters, galaxies, and so on. I also observed variable stars and sent my observation to the Hungarian Association and also to the AAVSO, the American Association of Variable Star Observers. However, during my university studies, I had less time for observations, so I became a professional astronomer. But I still look for opportunities to watch the sky when I get an area with less light pollution. I would like to stay a bit with my early years. In the early 90s, we have lots of visitors in Budapest. One of them, Nándor Balázs from Stony Brook University, which is in Long Island, was the last assistant of Einstein. He was a friend of Eugene Wigner, the Hungarian Nobel laureate. Not only he had great ideas, he also told us lots of anecdotes about these famous physicists. He also worked with Schrödinger in Ireland. In the early 90s, I worked with Béla Lukács on black holes. Some years later, with György Pál on cosmology. That time, also a Hungarian-born Peter Mészáros visited our institute and was looking for help for gamma-ray burst cosmology. So when I visited Nándor Balázs on Long Island, Peter invited me to visit Penn State too. A year later, I spent a year at Penn State working on gamma-ray burst cosmology with Peter. Before my visit, Zsolt Bagoly spent 2 years in Penn State. Also, another native Hungarian from Prague, Attila, visited Peter twice. During my stay at Penn State, Peter invited Lajos Balázs, the director of the Hungarian Konkoly Observatory, to work with us. Therefore, Peter was the founder for our high-energy astronomy research team. These 5 people were the core of our research group. The next 3 decades, we published more than 100 scientific papers together, mostly on gamma-ray burst, and received several research grants. More than a decade ago, we started to work with Professor John Hakila, who now is an associate provost at the University of Alabama in Huntsville. Around 2013, our analysis of GRB spatial distribution revealed an unexpected clustering of bursts in a particular region of the sky, corresponding to redshift around 2. When interpreted cosmologically, this cluster appeared to trace a structure spanning nearly 10 billion light-years, making it one of the largest known features in the observable universe. What makes this so fascinating is that such a size seems to exceed the limits preceded by the cosmological principle, which assumes that the universe is homogeneous and isotropic on scientific large scales. The Great Wall doesn't necessarily invalidate the principle, but it invites us to refine it. Perhaps the transition to large-scale universality happens at greater distances than we previously thought. Or maybe gamma ray bursts trace a particular type of matter distribution not perfectly aligned with galaxies. The scientific community response has been mixed but constructive. Some colleagues are cautious, suggesting that the pattern might result from selection effects or incomplete sampling, while others have found supporting hints in quasar and galaxy surveys. What is clear, however, is that GRBs have proven to be a valuable new cosmological probe, capable of revealing structures that traditionally surveys might miss.
And what's the most memorable moment you had in your scientific career?
I already mentioned with George Pal and Bela Lukács, we found it is likely to cosmological constant is not zero. That was very surprising. The other memorable was when I found out the reaction of the suggestion of the Hercules Corona Borealis Great Wall. First, it appeared in Wikipedia, and later there were a huge media response. Scientific videos came out saying the biggest structure is in our universe is the Hercules Corona Borealis Great Wall. Journalists asked us several times and interview about it. So we asked Professor Hakila, the co-founder of the Great Wall, to take the interviews. He did a very good job. As you can, both within and beyond your field, because discoveries often happened where two ideas met. Be patient. Progress in science takes time, and failures are almost as important as successes. Also, don't be afraid of big data or artificial intelligence. These are tools that will help you see patterns that older generation could only imagine. Follow your dreams and try to do what you really like to do.